Mathematics, grade 12. Okay, NOMSA started working on 1 January 1970. At the end of January 1970 and at the end of each month thereafter, she deposited 400 into an annuity fund. She continued doing this until she retired on 31 December 2013. So now we have to determine the total amount of money that you paid into the fund, not how much the fund gained or how much the final money was in the fund, just how much she has paid into the fund. So it's going to be 400 then multiplied by the number of years that she paid, which is going to be 2013 minus 1970 plus 1, right? And then these are the number of years. And then you have to remember that this person hasn't been paying on a yearly basis, but on a monthly basis. So to get to months, we have to multiply by 12. So this is going to give you 211200. So that's how much she paid into the fund. Okay, 7.1.2. The interest rate on this fund was 8% per annum, compounded monthly. Very important. Calculate the value of the fund at the time that she retired. Okay, so now we are looking at how much the fund earned. Okay, now she paid 400 every month. And then our interest rate is 0.08 divided by 12 since it's compounded monthly. And then the amount of months will be just this part. So from the first part, this is your n for this. So that's your n. Whatever value you got there is your n for the next step. Okay, and you should get 528 minus 1 divided by the interest rate. And then your final for FV should be 1,943,524,42. Okay, and then 7.1.3. On 1 January 2014, NOMSA invested 2 million into an account paying an interest rate at 10% per annum compounded monthly. NOMSA withdraws a fixed amount from this account. So withdrawals, present value. So at the end of each month, starting on 31 Jan 2014, if NOMSA wishes to take monthly withdrawals from this account for 25 years, calculate the maximum amount she could withdraw at the end of each month. So here is our formula, FV, no, not FV, PV, sorry. PV for present value. Then 1 minus 1 plus I to the negative n divided by the interest rate. So we have that she invested 2 million, which is PV. We have the interest rate, and we have n, which is 25 years. But then since it's being compounded monthly, that means we must multiply the 25 by 12. So we're going to have our 2 million this side, and then we do not know what x is. So our interest rate is 10%, which is going to be 0.1 over 12, so it's compounded monthly. And then here you're going to have 25, negative 25, negative 25 times 12. Okay, and then divided by our interest rate. Then you cross multiply by 0.1 divided by 12, and then divide by the square bracket. And negative 25 times 12 should give you negative 300. And then our final for x should be 18,174.01.